Hey guys, there's a couple measurement lab stuff I wanted to go over with you before you started to do the lab, mainly just how to use the equipment. The first thing I want to talk to you about is a thermometer. Now I know the thermometer is very basic and you probably all used one before, but there are two mistakes that students usually make with these. First thing I want to point out, and you know this from your notes because you're all highly engaged in them, is whenever you're taking measurements in temperature, you always read from the Celsius side. So if you look at the thermometer, Fahrenheit's on one side, Celsius is on the other. Make sure you're looking at the Celsius side of it. The other big mistake that students do is they measure temperature, they'll put it in a beaker of water, they take it out, and they shake the thermometer because, I don't know, they just feel like I have to shake it off or something. Don't do that. Okay, don't ever do that. It used to be mercury that was in thermometers, but now in that little red bulb, it's some form of alcohol. And if you take the thermometer out and you just start shaking it to get all the water off and you look at it, what you can do is break up that liquid and cause there to be air bubbles in it. And when that happens, the thermometer is broken and can't be used again. So try not to ever shake your thermometer off. Just dip it in the water, look at it, read the temperature, write it down, and put the thermometer away. Okay, so don't shake thermometers. The next thing I wanted to talk to you about was as far as measurements go. Again, this is super basic, but remember we always use centimeters or meters or millimeters. We do not use inches in science ever. So when you do your measurements, if you make these measurements in inches, you have done the whole lab incorrectly. So looking at the ruler, the top part is inches because they're larger. On the other side, the smaller side is centimeters. And like I tried to show you in that drawing from the notes, the really tiny spaces in between, those are millimeters. So centimeters are the medium-sized lines, and millimeters is the smallest lines. So when you do a measurement, because it's going to ask you to measure the volume of a box, I have students who will start to argue on if this is what's considered length, width, or well, height. They pretty much understand, but which side is length, which side is width. It doesn't matter, okay? You're multiplying all three numbers together. So I don't care if you think this is length or if you think this is width. Who cares, okay? When you multiply, you get the same answer because multiplication is commutative. I'm pretty sure I'm saying that right. So don't argue over stuff like that. Just do your measurements, multiply it together with the calculator, and you should all be good. The very last thing to go over is your scales for mass. So this is an electronic scale. This is a triple beam scale. The electronic scale, the first thing you have to do is open it, okay? Always open the scale. You'd be amazed at how many people are like, Ms. Collins, the scale doesn't work. And all I have to do is go over and open the case on it, and it all of a sudden works. So open the scale first. The next thing you do is you turn it on, which again is very basic. Now, this is going to have all sorts of numbers because I'm moving it. But you want your scale to always be at 0. If you are going to measure your weight, you want to get on a scale that doesn't already say 30 pounds. You want to get a scale that starts at 0. And so that's what we want to do with this scale and this electronic one. We always want to zero it out. The way you do this, some scales will say 0. This one doesn't. This one actually says tare. So you turn it on, and when it's sitting flat, the number should stop moving. You press tare one time, and it would go to 0. Now, it's not because I'm holding it up, but if it's on the table, you press tare one time, and it goes to 0. Please do not press PCS or mode. I don't know what those buttons do, and if you get it off the right mode, I don't know how to fix it. So don't press anything else other than on and tare. Okay, tare is 0. On and tare. Don't mess it up. Okay, I'm not there to attempt to fix it, which I probably couldn't even if I was. So on and tare. So you'll set it flat, press tare, it will go to 0. You'll set the object on the scale, and you'll get the mass for it, and that's in grams. So that is pretty much all there is for your electronic scale. Don't put anything super heavy on it. It'll tell you if it's too heavy to read it. But if you're like, ooh, I'm going to weigh myself, and you start pushing on the scale, okay, that's stupid. Please don't do that. It's going to break the scale. Same with this one, okay? This one is very finicky, and if you put really heavy objects on it or just start pushing on this, it will mess it up. And I don't have the money in the budget to buy a new one, so don't do that because I will be very angry and I will come and get you. So this is our triple beam balance, and you saw a picture and we briefly went over how to read it. This also has to be at 0, and I'll try to move this better so you can see it. When this stops moving, this says 0, and so when that line is matched up to that little line, that's when you know the scale's at 0. If your scale is doing this, don't sit there for 5 minutes because your time will be up. You can put your finger there and just kind of stop it, and it should balance itself out a lot faster that way. So you're going to put an object on the scale. Let's say I want to take the massive hand sanitizer. I would put it on the scale. It's obviously not 0. It's way up. So what I'm going to do is I'm going to move the heaviest weight over one at a time. Okay, the heaviest weight over one at a time. The heaviest weight is this largest one, so I'll move it over once. It's still over, so I know that this weight is not heavier than what's over there. Move it over one more time, and it dropped. So that tells me this is too much weight. So what I'm going to do is move it back one space to where it was before. Is that one space? Okay, one space to where it was before. Now I'm going to go to my second heaviest weight, and I'm going to move that over one at a time, which is this back one. So I'll move it over one at a time. Now it dropped, so I know that's too heavy, so I move it one back. And now I go with my smallest one, and I just kind of scoot it over. And as I do that, it should work. Why aren't you working? Okay, let's try again. So I'll move that over. Oh, I scooted too far back. So I move that over. And now I can scoot this over little by little. And it should start to balance out. And it can be, like I said, very finicky. So there, I have it balanced. And now to get your mass, you simply add up the numbers. So whatever this one is on, plus this one, plus this one. So remember, this is your hundreds place, your tens place, and your ones place. So you're just adding those 3 numbers together. That should give you the mass. If this is taking you a really, really long time to get something balanced, because sometimes the more practice you have, the faster you get with it. So if you have, because you're going to have 2 groups at that one station, and this one does take long. So if you're running out of time, if the 2 groups need to help each other take measurements for one thing and share that data, that's okay. Just make sure that you're being mindful of the time and that you're not goofing off and you're getting your work done. And I want to make sure that there's at least one partner from each side that has experience using the scale, because there's a good chance that you will use these again in chemistry, and having a little bit of background does help when you get there because you're expected to have that background. Last thing. Very last thing, let's move this over. Oh, and the last thing you do when you take this off, move everything back, so that then, I don't know why this isn't working. I'll have this fixed before y'all start your lab, but it can go back to 0 for the next group. So we'll just move this aside. Okay, water displacement. So you may remember me telling you some people are super eager to just drop the rock in the test tube or the graduated cylinder, and they don't take the initial volume. When doing water displacement, always take the initial volume. So you'll drop the rock in there. Hopefully it doesn't splash too much. You'll read the volume or subtract the volume from what the initial one was. Before you rotate to your next group, you need to reset this for them. So that's why you have this large empty beaker. You just pour everything in there. The rock's in there. I can take the rock out, set it on a paper towel, and then I can just pour the water back in. And we're all reset and ready for the next group to start. So make sure that you do that so every group can, as soon as they sit down, just go ahead and get started and you don't waste their time. Okay? Well, that is everything. I hope your lab goes well, and I hope you enjoy the rest of class, and I will see y'all in a few weeks.